Welcome to this episode of Mr. Lehman's Knowledge Explosion. In Lesson 1 of Unit 4, we're going to discuss what congruent figures are and do a quick refresher of the different types of triangles. So to start, there are two different ways to classify triangles. We can classify them by their side lengths. So any triangle that has all three sides the same would be considered equilateral. Any triangle that has two sides out of the three the same would be considered isosceles. And any triangle that has all three sides different lengths would be considered scalene. If we wanted to measure them based on, or classify them rather based on their angles, any triangle that has all three angles acute would be an acute triangle. If all the angles were the same, we would call that equiangular. If there was exactly one right angle, we call that a right triangle. And if there's one angle that is bigger than 180 degrees or an obtuse angle, we call that an obtuse triangle. When we're classifying these triangles, we want to be as specific as possible. So right now, with no markings on this triangle, the best I could do is call it scalene, because I don't know if any of the sides are the same. We usually try and do two terms. Is it right scalene? Is it acute scalene? Is it obtuse scalene? And so on. But I can't do that unless I gave you more information. So if I give you that marking there, now we know that there's a right angle in this triangle. We never assume. So I could call this a right scalene triangle. Now, for right and isosceles triangles, there are specific terms we want you to know. So if you know you're looking at a right triangle, we want you to know that the longest side of that triangle gets a specific name, which you've probably heard before, the hypotenuse. And the other two sides we call the legs. Doesn't matter which leg you call A or B, but they're both legs. On an isosceles triangle, the two sides that are the same also get called the legs of the isosceles triangle. The side that is different is always referred to as the base, and the angle that is connecting the two legs is always called the vertex angle. So I want you to know those terms because you might see a problem where it refers to the vertex angle or the base, and you need to know what those are. Now, last time in class we proved that there are 180 degrees in every triangle. I want to show you a different, more direct proof to this. So for example, if we start with triangle ABC and we know that AB is parallel to CD because that was given. So we construct it that way so we can work with the parallel lines. I know right away that the measure of angle 4 plus the measure of angle 3 plus the measure of angle 5 is going to equal 180 degrees because of the angle addition postulate. And I'm going to put a note here that says, straight angles equal 180 degrees. Oops, not congruent to, but equal 180 degrees. So it's the idea that angle 4, angle 3, and angle 5 are all together on that straight angle, so it has to add up to 180 degrees. Now I'm going to use the idea of the parallel lines to say, you know what? Angle 1 is alternate interior to angle 4, and so is angle 2 alternate interior to angle 5. And if those lines are parallel, which they are, that means angle 1 is congruent to angle 4, and angle 2 is congruent to angle 5. So if my lines are parallel, then my alternate interior angles are congruent. Which means my last statement can simply be angle 1 can take the place of angle 4 because they're the same, and angle 2 can take the place of angle 5 because they're the same, and angle 3 is still there, equals 180 degrees. So if you're not seeing what I'm doing, I'm taking statement number 2 and I'm replacing 4 and 5 with angle 1 and 2 to create a new statement using substitution that says, you know what, those three angles have to equal 180 degrees. That's a theorem you know, but I wanted you to see the proof one more time so we know that that's a guaranteed idea that we can use. A corollary is nothing more than a simple theorem based on another theorem. For example, if I told you that this was a right triangle, you know that this measures 90 degrees. So the corollary says the acute angles of a right triangle are complementary, because if we know, we just proved there's 180 degrees in a triangle, if we take out the 90 degrees for the right angle, that leaves us 90 degrees. But that 90 degrees has to be split between these two angles, 1 and 2. So all I know is that the measure of 1 plus the measure of 2 has to equal the leftover 90. It could be 60 and 30, 45 and 45, 10 and 80. But no matter what, they're going to be complementary because they add up to that leftover 90 degrees. Now here's another theorem about triangles. It says the measure of an exterior angle, like angle 1, is equal to the sum of the measures of the two non-adjacent interior angles. So this angle right here, we could call it angle 4. Oops. We call this angle 4, is adjacent to angle 1. So we're talking about the two non-adjacent angles 2 and 3. This theorem says that the measure of angle 2 plus the measure of angle 3 should equal the measure of angle 1. And without getting too much into the proof, here's the main idea. This angle 4 is a linear pair with angle 1. So angle 1 and angle 4 equal 180 degrees. But angle 2 and 3 also add up with angle 4 to equal 180 degrees. So if angle 1 was 100, that means angle 4 would be 80. But since 3 and 2 have to add up with that same angle in the triangle to make 180, that leaves me 100 degrees left over for 2 and 3 together. So 2 and 3 equal angle 1 no matter what. And we call that the remote interior angles theorem. So if you want to think of that as just a simple name, it's called the remote interior angles theorem. Now the main idea of this lesson is about congruency in triangles. Congruent figures means all angles are congruent and all sides are congruent. That's what a congruent figure is. So on these two triangles, if I wanted to say they're congruent, I would say one side has to match one side of the other triangle, a second side has to match a second side, and a third side has to match a third side. But that's not enough. To be totally congruent, one angle has to match another angle, a second angle has to match a second angle in the other triangle, and even the third angle has to match the third angle in the other figure. So when we say congruent figures, we're saying all parts of that figure are the same, all the sides and all the angles. So when we write a congruency statement tells you which things are the same. So I should probably label this triangle as A, B, C, and let's say X, Y, Z. My congruency statement would sound like this. Triangle A, B, C is congruent to triangle, and now I have to be careful. I have to make sure I'm matching up the correct pieces. Angle A was the same as angle X, so I have to start my next triangle with X because that matches A. And then I went to B. Angle B matched angle Y, so that needs to be the next letter in my statement. And then finally angle C was the last letter, which matched angle Z, so that would be triangle XYZ. Now you might be asking, why is that so important? Well, that becomes important because now I can just read the congruency statement and figure out which parts match up. For example, AB are the first two letters, so I could say AB is congruent to XY, the first two letters in the next statement. And if you look, AB was the same as XY. And I should be able to say the next two letters BC are congruent to the next two letters YZ in the other statement. And then the first letter A and the last letter C, so AC, should be congruent to the first letter was X and the last letter was Z. So if you give me a congruency statement, I don't even need to look at the picture. I can look at your statement and I know which pieces of those figures match up. Likewise, I could do the same thing for the angle. Since letter A came first, it's congruent to angle X, which came first in the other statement. Angle B was the second letter, so it should be congruent to angle Y. And angle C was the last letter, so it should be congruent to angle Z. So the reason we like congruent statements is because from that statement I can tell you all the things that are equal or congruent without even looking at the picture. So that's the main idea from Lesson 1, congruent statements and classifying triangles. Do the practice from Lesson 1 and see me if you have any questions. Good luck.